Hi, we introduce Auto4D, an automatic labeling pipeline that learns to generate 4D labels from sequential point clouds. The traditional workflow for developing ML models in the context of self-driving requires large amounts of human annotations to generate high-quality labels. However, producing these annotations is a tedious, time-consuming, and expensive process. In our work, we focus on automating the labeling process with a learned model named Auto4D, which generates temporally consistent object bounding boxes in 3D plus time. Most previous works on auto labeling focus on generating image labels such as object mass. Other approaches generate 3D labels from either 2D detections, 3D locations, or 3D detections. However, these methods only generate frame-wise labels and do not have temporal consistency, which is important in our self-driving application. In contrast, our approach directly operates on 4D object trajectories. Our model takes as input the sequential point clouds over time, as well as a set of initial object trajectories. Note that these initial trajectories don't have to be of high quality. In practice, we use an off-the-shelf object detector and tracker to compute them. The key idea of our approach is to decompose the 4D labels into two parts: the 3D size of the object that does not change through time, and the motion path describing the evolution of the object's pose through time. We solve for these two components by exploiting a two-stream architecture. First, for each initial trajectory, we aggregate the LiDAR object observations across time in the box coordinate system. This provides a noisy reconstruction of the object's shape, as the initial detections are far from perfect. We then use an encoder-decoder architecture to predict the object's size. We can apply the re-estimated object size to the object and get a refined trajectory with fixed size. We then aggregate the object observations again, but in the world coordinate system this time, to preserve the original motion information. We extract LiDAR observation features and exploit object motion features from the path and learn to refine the object pose at each time step. We now show some qualitative results of our approach. We draw 4D object labels in LiDAR bird's eye view. To avoid clutter, we show a LiDAR history of 2 seconds and a trajectory history of 1 second. From the results, we see that our approach is able to produce stable bounding boxes for parked vehicles and accurate and smooth trajectories for moving vehicles.